Okay, so the third alternative, so we've done x is less than, we've done x is greater than, now we'll do x is between A and B. So, oh look, we've got machine filling paint cans again, 10.1 litres, blah, blah, blah. Okay, and the boss wants to know what percentage of the cans contain between 10 and 10.2 litres. So that's really what he wants them to have. So our value of interest is that. So what we have to do is that we find this area here, which is the one from 10 downwards. So that's this bit here. And we also want to find this bit here. So that's that bit there. And so if we want the blue shaded bit, basically we take the green bit, subtract the pink bit, and that gives us the blue bit. So that's the green bit, which is less than or equal to 10.2. This is the pink bit, less than or equal to 10, and the blue bit, which is between the two, is the bit we're interested in. So the answer is that 49.5% of the cans contain between 10 and 10.2 litres. Okay, still not time for the break. Goodness me. You can tell I want a break. Okay, yeah, we're going to do this and then we'll have a break and then we'll work backwards. Okay, this is what threw a few people in the quizzes last year. Is that so far all of my answers have been percentages or probabilities, but sometimes we want to know numbers. Okay, so sometimes you want to know how many are within a certain range rather than the probability of an occurrence. So it might be that I say there is a 70% pass rate in this course, so or I say what the mean, the standard deviation is and this sort of stuff, and you actually want to know how many people does that mean. And so all it means is that you then, when you've got your probability or your proportion, you just multiply that by the total and that gives the numbers that fit in your particular bit. So here, factory produces 2,000 cans in one day. How many of them would you expect to contain over 10.4 litres? Okay, so earlier in this previous one here, on page 7, we found that the probability of a can being overfilled was 0.023. So we simply take this number here and multiply it, and we find that it equals 46 cans. Okay, now can you see how that could be useful in a business? Okay, there are several ways this can be useful. One is that you can decide, wow, 46 cans a day with paint coming out of them and not being able to sell is actually quite a lot. We might want to either make our cans a bit bigger or make our machine a little bit more accurate so that we're not going to spill so much paint. So that's one way we can use it. Another way we can use it is that we can keep track of how many overfilled paint cans there are, and it's a way of seeing whether our machine is still working properly. If it's working properly, we're expecting 46 cans. If we get 50 cans in one day, do you think there's a problem? Hands up those who think there's a problem. Okay, I don't think so, because 50 is not much more than 46. Okay, a problem in terms of more than what you'd expect. Okay, what about if we had 200 overfilled cans in one day? Okay, can you see what's happening here? So somewhere along the line, so 200 overfilled cans would mean that something has gone wrong with the machine. We expect 46 because of the way it works. If we get 50, that's around 46, so we don't really worry. 200, there is something wrong, we have to readjust the machine. So it gives us an idea of when to start fixing up production problems. And this is part of what you learn in MSci 221, which is production planning and control. And it's about making sure that processes work well. I mean, the same thing applies to service industries as well. Is that, say you're in charge of a hospital and you know that doctors usually see a certain number of patients in a day, and you find one doctor that's always seeing fewer patients or more patients or something like that, it helps you to be able to work out whether things are within what you would expect the variation to be or outside of that variation. And this is the pivotal idea behind inferential statistics. So this is a sneak preview into what you do probably mostly in Module 6, is that in inferential statistics you're saying this is what we believe the reality to be, and this is what we're taking a sample, and we would expect the sample to be a certain way. Now I'm going to look at the sample, and it is, if it's within a certain range of what we expect, then we'll say, yeah, no, the reality as I perceived it is probably correct. But if it's way off, then you go, right, there's something funny going on here. So it might be something to do with, more to do with the paint cans, is that we believe that they're filling to a certain amount. We actually check and we find that the mean is a bit higher. But how do we know how much is a bit, how much is a problem, and how much is just random variation? And that's where the normal distribution and the theoretical probabilities come into, because we can say, this is how likely we would expect to get this result. Okay, say we have chocolate bars that are meant to weigh, say, 100 grams, and we keep checking them to see them, and if we found that 10 of them all weighed over 150 grams, clearly there's a problem. But if 10 of them weighed over 100 grams, it doesn't look to be a problem. But what we need to know is, where is the line between where there isn't a problem and where there is a problem? And that's where the p-value, which you'll learn about in Module 6, comes in. So that's just a little of a sneak preview there. And that's where we're leading to with all of this probability. Okay, have a break for a couple of minutes, and then we will go backwards.